Hi, my name is Bailey Gravenhorst. I'm here to talk about my research proposal, which is the relationship of hydration in marathon runners to maximize performance on race day. This proposal was actually inspired by Breaking 2. It was a study that was done by National Geographic. They took 3 elite runners, Nike sponsored it, and their goal was to try and achieve sub 2 hours, while theirs was to peak performance to maximize to get to the time under 2 hours. Mine focuses more on fluid ingestion and if certain fluids drank throughout the race actually have an effect on performance, and if so, which ones seem to be the most beneficial. So a little bit of background and introduction. What is a marathon? We know it's a grueling 26.2 miles, which equates to 42.8 kilometers. These races are done all over the world, and throughout the years, the numbers continue to increase. How many people compete each year in a marathon? A study done in 2009 found that more than 397 marathons took place in the United States with more than 468,000 finishing times. So roughly each year that was done in 2009, and then we saw the increase was seen to 2010. It's a 10% increase about every year. And then another study by Murphy and Lee found that from 1980 to present, there has been a 32% increase in participants. So some people, the biggest question they ask is, why is fluid ingestion so important during a marathon? It's because it's a long duration event. It's 2+ hours that a person is running. There's great water loss via sweating, especially with the environment. A lot of temperatures are not always what they need to be, so you're going to have an increased core temperature. Potential consequences are going to be dehydration, hyponatremia, and these factors all have shown to inhibit performance. So this is just a chart that was found that Japan took. They took it worldwide. They also compared the US as well as Japan and marathon runners that ran and races that took place. So you can see from 2006 up into 2015, there's been great increases in the numbers of people that have finished a marathon. So the major issue with marathon running, as I discussed in the introduction, is the increase in participants put more people at risk for health issues, just because a lot of people are participating but don't know the full effects of a marathon on the body. There's dehydration, hyponatremia, there's an increased core temperature, which leads to sweat, and then electrolyte imbalance in the body. Originally, fluid intake was actually advised against. This was a study done by Noakes, and they said that when you drink fluid, you're actually fatiguing the body. But now it is found that athletes need to ingest a fluid containing the high sodium concentration for the replenishment of water loss, because water loss a lot of times can rehydrate the body, but it doesn't put the sodium and electrolytes back in that are lost. So the purpose of the proposed study is to evaluate the fluid ingestion for marathon runners. The big question is, how does the body ingest, obtain, and utilize fluids during a marathon to peak performance? Does it have an effect to the individual? If so, what fluid will be the one to peak performance the best? For the hypothesis that I formulated, I thought that there was going to be a correlation between fluid ingestion and performance of marathons, just because of the research that has shown that, opposed to back a while ago in the day from Noakes, that you're not supposed to intake fluid, but now I believe that you do need to intake fluid. So there will be a strong correlation in the aspect that the body will be less fatigued and you'll be able to maximize performance. It's also beneficial for recovery. You'll avoid the exercise-induced collapse at the end of a race, and the fluid to have the greatest effect on the body, I believe, will be a water fluid in addition to the electrolyte-based fluid. The significance of the problem, hydration during exercise, I do not believe is stressed enough, because so many runners are trying to just peak their performance and get the maximum out of the race that they're doing and lower their time. They forget about hydration, stopping at the rehydration stations during the race. It's a 2-hour+ event. You have to rehydrate, especially if you're running at an elite pace. You have to be able to rehydrate your body to not fatigue your body and continue. It's important to address these issues so athletes sustain good health as well as their ability to complete the race in proper performance. There was a study done by Piper in 2012 that found 73% of marathon runners failed to meet the comparatively low recommendations of food and fluid ingestion during the duration of it. So clearly, if 73% of all the people running a marathon are not intaking the proper fluid, their performance can be much better. These are just some definitions that I want to clarify for the purpose of the study. Marathon I discussed. Dehydration we know is excessive loss of body water via sweat. Hyponatremia is the amount of water in the body is too low and can occur in dehydration, except here the kidneys retain the water, so not enough water is being excreted that's being taken in, and the sodium, there's a sodium imbalance with the sodium as well as within the blood. Elite runner for this study, the people I want for this study, I want to be under a sub 2 hour 30 minutes. I want them to range from 24 to 30 years of age, and I want solely males, just so that there's no discrepancy in the training. And then electrolytes are minerals in your body that have an electrical charge, importance because they balance out the amount of water as well as the body's acid/base pH level. So some delimitations for the study could be faced with the researcher. There's a lot of data that's going to be taken, just fluid ingestion, nutrition is going to be evaluated, the training protocol, and then the day of the race day. The demographic set, because it's confined to the elite runners, some people may have an issue with the definition I've come up with for elite runners. And then potential limitations, it's going to be hard to find that specific group of elite runners that spans across worldwide and international. And then there's going to be a lot of energy and time that's required from these subjects, so it's a lot of rigorous training. So those are just some delimitations and limitations of the study. Now into the literature review. These are from the studies I found. Most endurance athletes are not reaching their fluid needs during exercise, facing consequences of hyponatremia and dehydration. These studies examine the cause and effects of fluid ingestion, likewise what occurs or can occur when athletes do not meet their requirements. It is well known that fluid and electrolyte balance are optimal for performance but more relevant to health. This was a study found in 2001. And then lastly, the need for fluid during a marathon depends principally on the combined effects of exercise intensity, body size, and environmental conditions of sweating rate. So it's not just one thing that affects the marathon runners, there's several different things, but for this study I focused on just the fluid intake. Just a little bit about the hyponatremia. It exists when the ratio of sodium is too low compared to the amount of water. Roughly 75% of energy produced dissipates as body heat, so sweat whenever you are running. The fluid loss through sweat is compromised of water and electrolytes, large amounts of sodium, small amounts of potassium, and calcium and iron. That was found in 2006 by a study done. So we know that sweat is needed to cool the body. When you have no fluid intake and it's just being retained, you can't sweat, your core temperature goes up, and then that will fatigue the body, inhibit performance. So dehydration does a little bit of the opposite. You're not taking in enough fluids, so therefore you will have a harmful reduction in the amount of water in the body. When you have a fluid deficient and you're exercising as long and as fast as you are for some of these runners, you're going to fatigue the body much more easily, and it'll make it harder to peak your performance. A study examined runners who drank a sufficient amount of water to keep their dehydration within less than 2% of their body mass, and body temperature was around 38.5 degrees Celsius, found that there was a significant correlation with temperature and the extent of dehydration. So if you're able to drink fluids, it helps the runner to be able to avoid dehydration, to therefore increase their energy and run the further duration at the performance needed. The electrolyte imbalance, just really quickly, I'm not going to go into too much detail just because I don't have a lot of time, but in events lasting longer than an hour, the fluids obtained should contain carbohydrates. So that's your Powerade, Gatorade, all of those that have the sodium, not so much the calcium, but potassium. A major change with induced prolonged exercise is obviously the change in sodium. We talked about that. With the imbalance, there's a shifting to electrolyte-free water balance, and it has to deal with the extracellular and intracellular fluid. This is imbalance during exercise through sweat. So the body's not at homeostasis because you're exercising. Like I said, when you exercise, core temperature increases, you sweat off all of this, and if you're not taking the fluids, the body is not allowed to do those things. So water versus electrolyte fluid, this is really what we're studying. It appears that only ingesting water can be problematic for long durations of exercise, causing high sweat rates. This was found in 2004. And then many studies have been concluding that sports drinks containing carbohydrates and electrolyte solutions have helped performance by saving the athletes from dehydration. So it prolongs when the time dehydration starts to occur. And then also sports drinks we know assist in electrolyte replenishment, speeds rehydration, stimulates rapid fluid absorption, and then it boosts the exercise ability. So then you can have good recovery as well. So summary of the literature review. We know that there are many associated components that take place in relation to peaking performance on a marathon runner. While there's other factors that have a role in maximizing performance, fluid intake is crucial to being able to maximize your performance. Okay, so for the methods of my proposed study, we're to look at the participants, the procedures, the projected timeline, the instrumentation, and then the statistical techniques. So for the participants, as I discussed earlier, I want it to be 60 elite runners. I want them to be international runners from all over the world. And I want them to be 24 to 30 years of age. I want them to be solely males, just because with males it's easier to keep the same training protocol. It's a relatively easier demographic to study with nutrition, strength and conditioning, as well as the race being run. There's no major discrepancies between men and women, so I'm going to stick to just males. And then I want an official marathon time of 2 hours and 30 minutes or under. For the procedures, it's going to take place at Florida Atlantic University. The exercise science laboratory at Florida Atlantic University will be where all the paperwork will take place. This will be the resting measurements, the heart rate, height, weight, BMI, and blood pressure. These tests will just be run to get a baseline. They won't really be run again until the final stage after all of the races have been run, just to compare some additional data as well as to see if that had anything to do with the fluid intake, if fluid intake was increasing body weight, decreasing body weight, all of those things. There will also be a brief questionnaire in regards to their previous nutrition, the fluid and food intake from their most previous marathon they ran, as well as the basic training they did. So that'll just be able to categorize each of the runners into certain groups and help the analysts, researchers who are going to take a look at it and put these runners into groups for the study. The other areas around campus will include training facilities such as the strength and conditioning gym, the stadium, the arena, and all of these will assist in training in preparation for race day. The strength and conditioning will obviously be used for the training protocol that's going to be written, and then the stadium and arena will just be used for running certain things that also are come up with by the training coaches. The racing will involve a course to the campus as well as with the nearby counterparts in Boca Raton. So this is just a table of the projected timeline. It's obviously a more lengthy study just because it is 21 weeks and I want to do a longer assessment. I want to do 4 training blocks. The first training block is going to be 4 weeks. This study will start in October and go through March. I know in Florida it can be a little bit hotter, but I tried to stick to October through March just because it's not the most extreme temperature here. And the biggest thing with marathon running in order to peak performance is you have to have a good environment that's relative to the body, and because the ability to sweat. Whenever it's hotter, you're obviously going to sweat more, so you want to try and keep it at cooler temperatures, but you don't want it too cold. So it was found, or in some research I did just with weather, the average temperature I think ranges from 72 to 78. It depends with Florida, but that's just important to note. The training block 1, like I said, 4 weeks, and then race 1 will be, it's a fourth of a marathon, so it's going to be 6.55 mile run. And then they'll have a week of recovery. Training block 2 will start 4 weeks, and then we'll have race 2, which is a 13-mile run, so a half marathon, recovery again, another training block, and then race 3 will be a 19.65 mile run recovery, the final training block, and then we'll do the race 4, which is the 26.2 mile run marathon. Each race that's run will be a very similar course, just to not have to worry about discrepancy and keep it reliable. So that's just a projected timeline. So it's obviously going to be very rigorous training. That's why I'm looking at elite runners. The instrumentation that's going to be used, fluid ingestion, I'm going to measure in milliliters. The food intake will be broken down by the nutritionist. Every runner is going to eat the same. They're going to train the same. Hopefully try and gain the same sleep relative to their body. But the biggest thing for running day will be the active Ipeco timing system to evaluate the runners. So it's basically a little tag that's placed on the shoe, and whenever you start, it starts the chip, and then whenever you finish, it'll get the time, and all of that goes into a database. So this is well-known, used for marathon running, 5Ks, 10Ks, half marathons. So that's what I'm going to use for the instrumentation. The statistical techniques, this is the most important part, I believe, of the study. You have 3 different groups. Group A, you're going to have 20, it's going to be broken up 20 runners for each group, but Group A will get only water during the race events. Group B, you're going to have 20 runners that are only going to get the electrolyte fluids. That's your Gatorade, your Powerade, your Pedialyte, all of those things that contain high sodium content. And then Group C, you're going to have 20 elite runners that are obtaining a water plus electrolyte fluid. So you get what Group A and Group B are getting all in just Group C. Throughout the training and recovery, Groups A, B, and C will follow. It's going to be the exact same protocol. Likewise, the nutrition plan will be the same as well. The only difference will be on race day based on the fluids that each group is getting. The independent variable will be the different groups. Fluid and the dependent variable will be the time ran. So again, assessing the fluid ingestion to see if it has anything to do with ability to run faster and avoid the dehydration, the hyponatremia, as well as fatigue. And then just a quick look. So through research, I hope to see that fluid ingestion will have an effect on performance, to peak performance, to get to that Breaking 2 that was run by the National Geographic. I know that in the study they did find that lack of fluid did have an effect, because he was able to run a half marathon at the time, the pace needed to make the 2 hours, but when he got past the half marathon, he started to dehydrate. Therefore, there was an issue in being able to maximize the performance. So I believe that there is an effect with fluid ingestion. The real question is which ones will be the best to optimize performance as well as recovery for the body and maintaining homeostasis throughout the long duration of the event. So that's all I got. Thank you so much. Here's my references. There's a lot. Have a great one.